All right, we'll do a quick tutorial here for graphing motion. The first one we're going to start with is position versus time. Then we'll talk about velocity versus time, and lastly acceleration versus time. So feel free to skip ahead or back and forth throughout the video to get to a section that you're having trouble with. So the first one's going to be position versus time. We can use these graphs to find velocity, acceleration, and displacement. As we found in our lab the other day, the slope of a position versus time graph is going to equal, the slope will equal the change in position divided by the change in time. So the average equals the average velocity. If we have a positive slope, we'll have a positive velocity. Okay? Positive slope equals positive velocity, and then we'd be moving to the right. Okay? If we have a negative slope, that's going to be a negative velocity, and we'd also be moving left. Okay? Positive slope, positive velocity, moving to the right. Negative slope, negative velocity, moving to the left. On a position versus time graph, the curvature is a change in slope of the line. So it shows the acceleration of the object. As we discussed in class already, if the curvature is concave up, that's going to mean that there's a positive acceleration. Okay, concave up gives a positive acceleration. If it's going to be concave down, that's going to give you a negative acceleration. All right, so again, the curvature is a change in the slope of the line, and that shows that the object is accelerating. So if you were given this x versus, or displacement versus time graph, you should be able to determine what's happening. So right now, hit pause and write down what's happening in each of these segments. The A, B segment, BC, CD, DE, and EF. So hit pause and jot down what's happening in those segments. All right, so first in that A to B segment, the velocity or the position time graph has a constant slope. So that means we are moving to the right, and again that slope is up, moving to the right with a constant velocity. Okay? In that BC section, that part of the graph is concave down. So we are still moving to the right, but in this case we're slowing down. So that would be a negative acceleration. Moving to the right and slowing down. Okay? Next we are in that C to D section right here. I think you guys all have this one covered. If your displacement doesn't change, so then you're not moving. So velocity equals 0 and acceleration equals 0. The next segment, D to E, okay, it's going to be a concave down section. We begin moving back to the left, and we are speeding up. So moving back to the left, we have a negative acceleration, so that velocity is increasing to the left. And then lastly, we're going to look at E to F. Our last segment from E to F, we're moving left with our constant velocity. That's essentially a straight line there. No curvature, so there's no acceleration. So we are moving back to the left, and we're traveling with a constant velocity. Okay, next we'll look at a velocity versus time graph. Okay, so if we have our velocity versus time graphs next, we can use those to find acceleration, displacement, changes in acceleration, and velocity. Again, in this class, acceleration is always going to be constant, so we're not going to worry about this in our little discussion here, but we could use this to find a change in acceleration. Okay? And then next we're going to calculate what's the slope of velocity versus time graph. Think about what the slope of a position versus time graph was. Of course, that was velocity. So what do you think the slope from a velocity versus time graph is going to be? You guessed it. It's going to be the change in velocity divided by the change in the time. And you guessed it, the slope is the change in velocity divided by the change in time. And we know that to be the average acceleration. So acceleration, average acceleration. Okay? If we have a positive slope means we have a positive acceleration, and it means we are accelerating to the right. All right? If we have a negative slope, we're going to have a negative acceleration, and we'll be accelerating to the left. All right? Okay, we're going to look at this velocity versus time graph. We're not going to worry, as I said, about any curvature. showing that there being a change in acceleration because our accelerations will always be constant. All right, so I want you to take a moment and think about what's happening in our A to B section, what's happening in the C or the B to C section, C to D, and lastly the D to E section. So hit pause and figure out what's happening in those sections. So for the first segment from A to B, all right, we are moving to the right because we have a positive velocity change and that velocity is increasing, so we're speeding up. Moving to the right and speeding up from segment A to B. B to C, you're still moving to the right, but you're doing so at a constant speed. So if you have a constant speed, that's no change in velocity, so there's no acceleration. All right, next we're going to look at C to D, so segment C to D. Our velocity is still positive above the axis, so we're still moving to the right, but that velocity is decreasing, so we're slowing down. Still moving to the right, but we're slowing down from C to D. All right, the next segment is going to be when we're at D. So when we're right here at D, we would not be moving, we'd be stopped. So right at D, we're momentarily stopped. Okay, next we'll look at from D to E. So again, last we're going to look at this segment D to E. So at D to E, we are traveling to the left, and speeding up. So we are moving to the left at a faster and faster pace throughout segment D to E. All right. Next, we will figure out how to determine displacement from a velocity versus time graph. So next we'll determine our displacement from a V versus T graph. Well, you guys know that velocity, average velocity just equals delta x over t. So if we were trying to find our displacement, we could just say that delta x equals v times t. So if we were moving at 2 meters per second for 2 seconds, you guys could figure out that delta x is 2 meters per second times 2 seconds. Well, that displacement would be 4 meters. All right, the interesting thing is that if you look at the area of this square, well, or rectangle, the area of that is also 4 meters, okay? So what you determine then is that on a velocity versus time graph, the displacement is the area between the curve and the origin or the time axis, okay? So the displacement's always going to be the area between the curve and the time axis. So in that last homework set or the last problem set we were doing in class, you'd have to break some of those shapes up into shapes that you could determine the area for, but it's always, that displacement is always going to be the area under the curve. And a key thing to remember here is if the area is underneath the axis, well then that displacement is going to be negative. That displacement will be negative. Okay? So if they have area under the curve, so this area here, if you were calculating that displacement would be a negative value because you would have a negative velocity. So if this was positive, this was negative, v times t would give you a negative displacement. All right, last thing we're going to do is move on to an acceleration versus time graph. Okay, for our acceleration versus time graph, this could be used to show acceleration, change in acceleration, and change in velocity. All right, again, we're not going to worry about this change in acceleration for our class because the accelerations are always going to be constant, but essentially the slope of this would be the change in acceleration divided by the change in time or the rate of change of acceleration. Okay? Again, we're going to use constant accelerations in our class. So if we have a acceleration versus time graph, just like we said for the velocity versus time graph, the area under the curve was the displacement. So if you have an acceleration versus time graph, the area under the curve is going to be the change in velocity. So again, if we're calculating the area under that curve, so from the first 3 seconds, that change in velocity would be 15 meters per second. From 3 to 6, there would be no change in velocity. From 6 to 8, that change in velocity would be a negative 4 meters per second. All right. So if we were going to add that all together, if we had a situation like this, the change in velocity would be a positive 11 meters per second. All right, that ends the podcast for acceleration or just, graphing motion. If you have any more questions, you can come in after class or after school tomorrow or before school on Friday and, of course, during class time. Thanks, everybody, and I look forward to seeing you tomorrow.